Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your introduction and history of agrochemical. This agrochemicals are also known as agri-chemicals. Agri-chemicals. Here you can see that this word are made up of two different words. One is your agro plus chemical which combine together and form a word that is your agrochemicals. Okay, simply in a agriculture field, agro means what? Agriculture, and these chemicals are what? The chemicals that we use. So when in a agriculture field, these chemicals are used. Okay, like your biocides, pesticides, fungicides, and your herbicides. They are what? They are a biocides for killing the microbes, for killing the insects, for killing the pest. Then these chemicals are come under the category of this biocides. Okay, when chemicals are used in an agriculture industry, then this term known as agrochemicals. Okay, so in today's lecture, what we are going to do, we are going to discuss about all these about the introduction and the history of these agrochemicals. Okay, so some agrochemicals are biocide like this one that we already discussed, and another one is your synthetic. In synthetic we study about the fertilizers come under the category of synthetic agrochemical. So let's start the today's lecture. Introduction. Global food consumption will be double in the next 25 years. Okay, if we talk about the next 25 years, then the food production in a global level will be double. And the reason behind this increasement is what? Increment in the world population. When a world population increases, the consumption of a single person increases, the demand increases, and ultimately the food consumption will also increases. And the area, that is your arable land, however, will remain constant. Okay, but we all know that population increases, consumption increases, but the area in which the farming are performed, this area are what? These areas are constant. Consequently, the available agricultural land area per person has decreased. Okay, for example, 0.5% HA per person in 1950. If we talk about the one person, then it covered 0.5 HA. But this data is taken from 1950 years. But today it reaches around 0.25 HA per person. Now, if we talk about the 2050, then it reaches to the 0.15 HA per person. So, which means that when our population increases, the demand increases, but the area which are come under the arable land, they are what? They are decreases. Now, the illusional challenge that agriculture faces to feed the growing world population, farm must produce more food on less land. Okay, so this is a very challenges which are faces by the agriculture industries, that they have to produce a more food, but this more food are will be produces in a less land area. Now, next, this is a graph between the population and arable land. Okay, So if we talk about the 1850, then it is around 0.8, then it is 1, 1.5, 3, population is increases and the land will decreases. Changes of the world population and area or of the arable land, that is your population in billion, arable land in relatively number. These sources are taken by a FAO statistic available from www.gao.org and www.syngenta.com. Now the next is your, this challenge is not new. If we talk about this challenge, then this challenge is not new. If we talk about the 200-year ago, then at that time the world population was about one quarter of that today. Okay, so if we talk about the 200-year ago, now at that time the world population are what? The world population are the one third of the, one quarter of that today's population, and much larger fraction of these days, much larger fraction of these people work on farms. Nevertheless, famine, malnutrition, waves of the pest and the diseases were very common in most part of the world, even though people were practicing agriculture in a similar way as we do today. That is your, we perform the seeding, growing, harvesting and storing. And the major difference between these are what? The traditional field management. Okay. Now the next is your, the oldest system of the food gathering is that of the nomads. Nomads are what? It is the oldest system of the food gathering. When there is a basic food supply get exhausted in one place, in nomads what happen? In nomads, this nomads are a oldest system of the food gathering. Okay, now in nomads what we do, we exhausted the food supply, basic food supply in a one place, and then it is migrated to a different area. Suppose that this is a one place in which we exhausted the basic food supply, then this will migrate to the different areas. In other areas, nature helped to keep the land fertile. For instance, in Nile Valley, the river flooded the land nearly every year and then regenerated the agricultural soil so that it make it ready for a new harvest. Then the rotational crop system also has a long tradition. One crop is planted in first year and different one in a second year, and then the land is left follow for a year so that it will regenerate before it is used again for a crop production. This is called a nomad system for the food gathering. Now the next is your mineral fertilizer. Mineral fertilizer, it is estimated that a traditional farming without chemical. Okay, so what we do, what farmers do, they do a traditional farming, but they do not involve any chemicals and mechanical support which can feed approximately 1.5 billion people. Okay, so the traditional farming come under the category of this use of this mineral fertilizer. They do not use any. So what they do not use any chemical in their farming, and also do not use a mechanical, and they give a mechanical support and feed approximately around 1.5 billion people. Today earth has a population around 6 billion, which means something has happened in between that led to an enhance the productivity in agriculture. Okay, so population is around 6 billion and they feed around 1.5 billion. So what we have to do, we have to enhance the Productivity in agriculture. The first step to a modern field management was that the introduction of the mineral fertilizer, and it began in 19th century, in which the world population grew rapidly and global famine was looming. Therefore, scientists work hard so that they find a solution for the improvement of the crop yield. The first important discovery was that the discovery of the organic carbon in a plant which come from the photosynthesis by using this carbon dioxide in air and not from a organic matter which contain in the soil. So this is a formula in which we use a carbon dioxide for the production for the improvement of the crop yield. Now the soil supply, which have what? Which have inorganic minerals and water. Justus Liebig, he an eminent German chemist. Justus Liebig, they he was a eminent German chemist and a teacher. He discovered that the four elements are very essential for the plant growth. And these four elements are what? It is nitrogen, phosphorus, calcium, and potassium. These are the four elements which are very important for the growth of the plant, and it is discovered by the Justus Liebig. He was a German chemist and a teacher. Now, after that, um, he also discovered some essential element that is called a trace. Sorry, after that, there are some essential elements that is called a trace elements were also discovered by the scientist. Then the growth rate of the plant is very limited by the component which have minimum in the accessible soil layer. When one element is in short supply, adding large quantity of the other element does not increase the yield. It is like the barrel in which the plank are of even height. When it is filled with water, the lowest plank always determine the capacity, no matter how high the others are. So this is a figure which represent the barrel picture which is used by the Liebig, so that it illustrated that the principle of the minimum needed essential element, and also the capacity of the barrel is limited by the length of the shortest staff in case of crop nitrogen, and can only be increased by the lightening that staff. It would not help to increase the height of the others. So this diagram represents that. Now the next is your in Liebig day, nitrogen was very limited element which are present in a soil. Therefore, he proposed that use of the natural nitrogen sources. So in the place of the nitrogen, what they use are natural sources of the nitrogen, like child saltpeter, guano, and manure to fertilize the field. In that, the productivity increased rapidly. Then a new food crisis loomed at the end of the 19th century, when the supply of the child saltpeter were nearly exhausted, and little that was left was reserved for a military purposes. The supply of the food for the world population was again at risk. Desperately, new sources of the nitrogen fertilizer were sought. There is an abundance of the nitrogen which are present in the air. However, plants are unable to use it because they cannot split these into molecules. Okay. Now, after that, there is a discovery of the catalytic reaction. This catalytic reaction are known as a Haber-Bosch process. solve that the conversion of the nitrogen problem and also hydrogen into the ammonia, and this ammonia are used as a starting material for all other type of the nitrogen compound. Nitric acid, for instance, is produced by the catalytic oxidation of the ammonia. Nowadays, this nitrogen fertilizer like your ammonium nitrate and ammonium sulfate or even urea are available in a unlimited quantity, and this is used as a nitrogen source. Now these time this nitrogen are not longer the limited factor which are present in a agriculture field, because it is present in a different form like your ammonium nitrate, ammonium sulfate, or even in a urea. Now the next is your crop protection. When our yield solve, only half the problem are solved, because at that time only yield are increases, but we have also protect that crop from the from the deterioration. So this is a big problem. Now you cannot say that if the yield are increases, now all the problems are solved. Only the half of problem are solved, and the crop must also be protected from the diseases and the pests. These are what? These are the other half problem. Without protection, around 50 to 90% of the harvest is destroyed by the pest. If the crop are not protected, then in that case, around 50 to 90% of the harvest plant are destroyed by the pest, and it is illustrated by the numerous disaster crop losses in the past. Following are a few examples which occur before the modern pest management which was available. The coffee industry of the Sri Lanka collapsed completely because of an infection by the coffee rust. There is a industry in Sri Lanka, that is your coffee industry, which are totally collapsed because there is a infestation by the coffee rust. About 50% of the annual cocoa harvest was destroyed by the cocoa bugs, that is your mildew. Furthermore, potato blind pest in Ireland, they are caused a disastrous famine that forced the minerals of the Irish to immigrate. The famine in India at the beginning of the 20th century, they caused a rice fungus which destroyed the rice harvest. Now farmers have tried to fight these and other pests throughout the history, but their means were very limited. Then the sulfur was the first material which are documented, which are discovered, which was used in the war against a infection. So we consider this sulfur is the first chemical which was used by the, no, it was around 3000 years ago by the Chinese as a somewhat effective fumigant. Some 2500 years later, then they use arsenic. It was introduced as an insecticide, and nicotine and strychnine in extract from tobacco leaves, and strychnos seeds respectively, and they are used as a rodenticides. Now the next is your letter. Then there is an extract taken from a plant, and which plant? That is your chrysanthemum, tobacco, or inorganic compound. For example, Bordeaux mixture, copper sulfate, calcium hydroxide, and water, and Paris green, that is your copper and arsenicide. They were used as an insecticide or a fungicide. With the rise of the synthetic organic chemistry after 1850, many new substances were discovered, and then they used for a biological efficacy. Today, around 1000 chemical substances are produced, which are produced as an active ingredients, which are used in some 10,000 different products. Then at last, genetic engineering. This is a latest setup which are created by our agriculture management, and it is development of the genetically engineered plant which produce food crop of high quality. See, with the help of this genetic engineering, what we do, we produce a crop, and this crop have a high yield, and they are also resistant to a pest, and they also does not have any adverse they does not have any adverse effect of the climatical condition. However, this technology is still in an infancy. We can be optimistic that it will help to feed the world population in future if the general public accept it. So this is about the introduction of the agrochemicals and the history of the agrochemicals. I hope you will understand. But if you have any query related to this experiment, you are free to ask me in a comment box, or for a further detail, you can follow the ITLS Academy on these platform, or subscribe our channel, or get our app. And then you can also visit our website, that is www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.